Right now I am considering whether or not to explain anything about the program or just talk about what it does. So I guess I'll talk about what it does. Um, this is, oh God, that's hard to explain. So the T is equal to a command, the output of a command, and maximize of something. And maximize means numerical maximization as opposed to symbolic maximization. It's possible to find the maximum using just variables alone, like solving for x and y, but and maximize will it can find a maximum even if there's like 100 variables, which there might be in real applications. Um, uh, okay, let me back up. Go to an Excel spreadsheet that I've got ready. Um, so in this spreadsheet, in column A, the number is 0 if there is no cancer and 1 if there is cancer. So this is a very basic classification problem where we want to determine what biases we might need in order to try to predict column A by looking at the correlation. And the correlation basically tells you is of two variables. Correlation is or more two or more variables. Um, and it basically tells you if there is a linear relationship, meaning that one of them is mx plus b, like so one of them is m, the second one plus b. Um, so if you notice up here, it says if rand less than 1.7 out of 300, that actually is close to the cancer rate in the country. 1.7 million cancer patients to 300 million Americans. And if it's if the percentage is low enough to go below this threshold, that person unfortunately would be having cancer with value 1. If not, in the vast majority of these cases, the number is greater than 1.7 over 300. So that's 0. So no cancer in that case. So you can see that, oops. So you can see that for column A here, most of them are 0. In fact, it's hard to find one that's a 1. So I'm at 200 and I still haven't seen a 1 yet. Um, Maybe I'm missing one. But anyway, 1s are rare. Okay. So what we want to do is based on, in this case, based on 1, 2, 3, 4, 5, 6, 7, 5, 6, 27, 28, 29, 30. For 30 variables, we each have this formula. Uh, some of these formulas, the first few are going to be this, and then the rest are going to be a different formula. So let's look at B. So this formula up here. Um, So this says if the random number between 0 and 1 is less than 0.5, so there's a 50% chance. If that's the case, then give the entry in A1, which is the cancer classification. Um, or if not, then give a random number between 0 and 1. Okay. So what this means is this um, column B is basically it says that essentially that it it predicts cancer correctly 50% of the time. Okay. And if it's not in that, if you roll the dice and get less than 50 on a two 10-sided dice, um, then in that case, it's a random number between 0 and 1, which has nothing to do with cancer or column A or column B. So column C is similar, column D, similar. Okay, now starting with column G, all the way to the end, see there's 30 variables here, all the way to the end, it's just a random number between 0 and 1. It has nothing to do with column A. It's totally random. So there are 1, 2, 3, 4, 5, 6, 5. There's going to be 5 variables that contribute to maximum correlation best, and then the rest of these, it's going to turn out they don't they make the correlation worse. So I'm going to put this into my formula, into my program, and see what happens. Here is maximizing correlation. Let me make sure noise 5 is what was loaded, because that's what's supposed to be loaded. This sets up the program, and here's the program. I'm going to run the program. T minus 10, 9, 8, 7, 6, 5, 4, 3, 2. Well, it took Mathematica about 10 minutes to get this solution. So each column, if you count the columns, there would be so A is the given target column, like has cancer, doesn't have cancer. That's something we have no control over. And then we're going to introduce bias. Each column will have its own bias. So if it's like 0.75, then we're going to multiply whatever it was by 0.75. And then column C has its own bias. And that bias it multiplies or somehow changes whether or not there's cancer predicted. So each of these each column basically represents a cancer predictor. It's just that they are all bad except for um, the first 5 columns are not all bad. Now, if you go to the solution, the the maximum or the bias involved was as low as 0, meaning that that variable is completely not involved. If we have some data rolling around and we're multiplying it all by 0, then that basically negates like the data. So each of these has a bias. And look how small they are. They're all pretty small. And then when you get to B24, that's the bias we introduced to column 24. It's 1.01, okay, 0.01, 0.02, 0.028, so it's going up. That's because I had it sorted. And 0.09, okay, so that's a lot higher. Now 0.12, 0.18, 0.21, 0.23. So 0.23 compared to all these other small numbers, these are the good cancer detectors. Okay, and the maximum correlation can have to be 0.17. That would be if you did the prediction. Pearson correlation coefficient would be 0.17.